Hello everyone. Here is the wall, and each square meter cost me only $5, which is even less than 400 Russian rubles. And all the walls will cost about $200. That's only 15,000 rubles. What do you think of the walls in this ultra-budget project? For this project, I'm constructing a house with a materials budget of only 1,000 United States dollars. And that's only 75,000 Russian rubles for the entire house. The wall is strong enough and immediately suitable for finishing without any extra work. The thermal insulation properties of such a wall are similar to those of a wooden beam wall 20 centimeters thick, or a brick wall as thick as 2.5 bricks. At the same time, my wall is no thicker than 4 centimeters. This is my first time working as a plasterer, and what kept me from falling flat on my face was that Earth's gravity or gravitation was on my side when I was making this wall. It helped me a great deal when I asked for its assistance. But let's take it one step at a time. Lately, I've noticed that the algorithms aren't favoring my new videos, and I can only explain this by saying that they sensed a threat from the information I'm sharing to the global centers of building materials production, since business still rules the world. If many people start building cheaply, the business will lose out on significant profits. And since we, ordinary people, are actually interested in cheap methods, I ask those who haven't subscribed yet to support my channel by subscribing and to share this video on social networks wherever possible. Thank you. In one of the previous videos, I leveled the foundation and even poured one wall from scratch. I used a permanent formwork made of polystyrene foam. It will later serve as insulation for the foundation. Instead of crushed stone, I used broken bricks as the aggregate for the concrete as much as possible and poured half of it. For the second half, I decided to make classic concrete. Cement, sand, crushed stone. Cement is the costliest, and I used 2.5 times less of it compared to using broken bricks. I bought leftover crushed stone locally at a low price. The sand is from a nearby river, so it wasn't expensive either. As insulation material for the walls, I decided to use these sheets of extruded polystyrene foam, only 30 millimeters thick. They are used for gluing under the base and creating a reinforced layer on them in the facade insulation system. The sheets are pre-milled for better glue adhesion, but smooth sheets can also be used if easier to obtain. Roughen smooth sheets first, such as with a wire brush, before use. I glue the sheets together with polyurethane adhesive foam. The glue bonds in about 20 minutes, and while it's still fresh, you can remove the excess foam like this. When the glue is fully set, it will come off the polyethylene film by itself. To speed up the process, I slide in a sheet of fiberboard. These walls preserve the project's main concepts. Like other components, they can be prefabricated in a convenient location and transported to the site ready for use. The structure is easy to disassemble, allowing you to take the house apart and reassemble it in a new location. I trim off the excess in height and add it as the missing part in width. I achieve the precise fitting of the future walls by placing the blanks against the frame opening that needs to be filled with walls. I leave gaps to allow the walls to be foamed to the frame. I glue the blanks for the next opening the same way. I cut fiberglass mesh according to the height of the wall elements. Next, I will use adhesive for polystyrene foam boards. Here are its specifications. The instructions indicate that only 11 pounds of adhesive per square meter is needed to create the reinforcing layer. I'm mixing it, and after that it's all about technique, which I don't have. But spreading adhesive on horizontally laid boards is as easy as playing with wet sand on the riverbank on a hot summer day as a kid. I go over the spread adhesive with the notch side of a metal trowel, press in the reinforcing mesh, and smooth out the adhesive. I can already anticipate the exclamations, "Yasha Kosyak, are the house walls really going to be plastered foam plastic?" No guys, this isn't plastered foam plastic. All of this gradually turns into a real composite material. A 10-centimeter overlap for the next mesh strip suffices. Using a wide spatula, I attempt to level the surface. Regular viewers of my channel should remember the video where I glued together a motorboat hull out of foam plastic. By reinforcing the weak material with a bit of fiberglass and epoxy resin, I ended up with a very strong boat. The finished structure will be stronger than its parts due to the sandwich panel effect, demonstrating the principles of strength of materials. For the experiment, I also used regular tile adhesive. It's also suitable for creating thin layers. I didn't notice any difference in the properties of these two mixtures while working. Whether there will be any differences in use, only time will tell. For a smoother surface, I applied a second thin layer after some time and leveled it with a spatula. Here's the result. After waiting for the surface to set a little, we turned the walls over. 3 of us did it together to reduce the risk of severe deformation, and as a result, cracks, since the glue was still far from fully set. I repeated the process identically, but experience gained from challenging mistakes allowed the surface to come out smoother right from the initial layer. Behind the scenes was the making of the very first test wall, which if it hadn't worked out right away, there wouldn't have been a reason for this video. I smeared it with a cement plaster mix, which is cheaper than glue, in one layer. I decided to add the second layer while it was already in a vertical position. Without experience, I have to say it's quite a challenge. For us amateurs, plastering in a horizontal position is much easier than in a vertical one. To temporarily secure the walls, I screwed in these wooden planks into the openings. I'm gluing waterproofing to the foundation using scraps of soft shingles for this purpose. Before installing the wall, I apply adhesive foam to it. Each wall element is about 4 square meters in size, and for each of these walls, I only used 1.5 25-kilogram bags of adhesive. The weight of a 4 square meter section, including the lightweight polystyrene foam and mesh, is only around 99 pounds. I intended to show how easily these walls could be moved to the installation site. However, I forgot to start recording with the camera.
We won't carry it back and forth again.
No. I think these walls are a great alternative to structural insulated panels. No one forbids using thicker polystyrene foam, and the thickness of the plaster can easily be increased from 3 millimeters to, for example, 1 centimeter. Anyway, it will cost less than an oriented strandboard board. I'm just on a super strict budget. You can also significantly improve convenience by using a special post and by making narrower wall elements so it's easier to reach their center. In future videos, I plan to practice installing such walls, doors, and windows, including American sliding sliders, and to completely finish the installation of the walls of my house. Excellent. As we can see, there are no particular difficulties when installing such walls. When building walls, for example, from foam concrete or brick, just the cost of hiring a plasterer to level them will be more expensive than the cost price of my walls. As shown, even amateurs can easily plaster such walls. Plasterers will soon be unemployed. I'm temporarily securing it with wooden bars. Recently, there has been a total increase in the prices of building materials, especially wood and iron, which means that we need to move away from using materials that have become unaffordable. On the right, the wall is made of glue, and on the left is made of a cement plaster mixture. To make sure that the walls are even enough right away for applying the final finish, I applied a decorative stone plaster with a thickness of 1.5 millimeters after first painting the walls with a primer paint, as the technology requires. It turned out pretty good. Only 2 kilograms of finishing material are used per square meter. I haven't seen any videos on YouTube about this kind of wall option. Maybe it's a know-how? $5 is not the final cost per square meter. It can be reduced even further. This time I didn't overthink it and bought everything at the first store I came across. But you can get a lower price by buying from the original supplier if you put in the effort to locate them. I just have ridiculously small volumes. You can also use cheaper foam plastic instead of extruded polystyrene foam, which is what I initially considered using. And only at the last moment did I choose the extruded one. Its almost zero water absorption won me over. The production and sale of construction mixes is a very serious and profitable industry. Typically, their formulas contain nothing supernatural. Making the glue yourself can save a lot of money. Combining styrofoam, homemade glue, and inexpensive fiberglass mesh, the entire wall will cost around $3. But I won't go that far. I'm already satisfied with what I have. Someone might argue that such walls have poor burglary resistance. First of all, nobody knows that yet because cement-based mixtures gain their strength in 28 days. In a month, I will thoroughly test it myself, but the wall already feels strong enough. Secondly, usually a thief breaks the door lock or climbs in through a window, and with modern metal cutting tools, any iron door can be broken through in just a few minutes. Nowadays, security is more often ensured by surveillance systems and alarms, not by fortress walls and heavy locks. So give it a thumbs up, subscribe to my channel, and also subscribe to my second channel, where a video about the partisans of the future and their supposed diet is coming out soon. The link to it is below the video. Also, hit the notification bells to stay informed. Thank you.